Hello and welcome. In this video, we're going to take a look at the solutions to homework on Unit 6, Lesson 4, Fractional Exponents Revisited. Remember to pause or rewind the video as needed. Let's take a look. Number 1, which of the following is equivalent to x to the 5/2 power? Well, we can start by remembering that x to the m over n, where m is the power and n is the root, we can rewrite this as the square root of x to the 5th power, which is just simply written like this. We don't need to write the 2. In number 2, if the expression 1 over square root of x was placed in x to the a power form, then which of the following would be the value of a? Well, 1 over the square root of x, that's the same as 1 over x to the 1/2 power. But if I write it in this form, it means I have to write it like a negative exponent. In other words, bring it up. And I do that, and therefore a, the exponent, is negative 1/2. Number 3, which of the following is not equivalent to the square root of x to the 9th power? Well, the square root is a second root. So one of the things I can do is I can simplify this and write it as the square root of x to the 8th power times x to the 1. I can take the square root of x to the 8th power because 2 is divisible into 8. Therefore, the square root of 8 to the x to the 8th power would simply be x to the 4th power. 8 divided by 2 is 4. Times the square root of what's left over that I cannot take the square root of, simply x. So that's one possibility right there. We want to know what it's not equivalent to, so I can cross that off the list. Well, the square root of x to the 9th power can also be written as x to the 9/2 power, where 9 is the power, 2 is the root, 9/2. So again, I can cross that off because we're looking for what it's not equivalent to. Well, x to the 9/2 power could be rewritten two ways. It could be written as x to the 9th power to the 1/2 power, which in this case it would be x to the 9th, or the square root of x to the 9th, which is what we have right here. But it could also be written as x to the 1/2 power raised to the 9th power. That's also 9/2. And in that case, it would be the square root of x raised to the 9th power. So I can eliminate that one as well, making x to the 3rd the only one that's not equivalent to the square root of x to the 9th power. In number 4, the radical expression 50x to the 5th power y to the 3rd power can be broken down into, I'm going to break this down into what I can take the square root of and what I cannot. So 50 can be broken down into 25 times 2. X to the 5th can be broken down into x to the 4th times x to the 1. Now, again, why am I breaking it up that way? Because this is a square root, a second root, and 2 is divisible into 4, not 5. And y can be broken down into y squared, which is divisible by 2, and the remaining y to the 1st power. Take the square root of what you can in black right there. The square root of 25 would be 5. The square root of x to the 4th power is x squared. The square root of y squared is just simply y to the 1st power. Times the square root of what's left over under the radical. Anything you cannot take the square root of, leave it under the radical. 2xy. And I can rewrite this without that 1. I don't need that 1. And the solution is 5x squared y times the square root of 2xy. Number 5, if 12 times the cube root of x was placed in this form here, y equals a to the x to the b power, ax to the b power, then which of the following is the value of a times b? Well, first of all, let's write it in this form. So y is equal to 12 times x to the 1/3 power. And there we go. Y equals ax to the b power. A would be 12, b would be 1/3. A is 12, b is 1/3. Now that I know what a and b are, we want to figure out what is the value of a times b. So a times b would be 12 times 1/3, which is the same as 12 divided by 3, which is 4. In number 6, we're going to rewrite each of the following expressions without using roots or fractional exponents. We're going to be using the property x to the, or the nth root, excuse me, of x to the m power. And we're going to rewrite that as x to the m over n. Well, the square root of x, part A, that's the square root of x to the first power, where 2 is the root, 1 is the power. We would rewrite this as x to the 1/2 power. Letter B, same thing. 3 is the root, 1 is the power. This is x to the 1/3 power. Part C is x to the 1/7 power. 1 is the power, 7 is the root. Part D, 5 is the power, 2 is the root. This becomes x to the 5/2 power. E, 11 is the power, 3 is the root. This becomes x to the 11 over 3. F, this is x to the 4th root of x to the first power. So this is the x to the 1/4 power. But I'm going to rewrite this as x to the negative 1/4. G, 3 is the root, 2 is the power. This is 1 over x to the 2/3 power. But again, I'm going to rewrite this as x to the negative 2/3. 1 over the square root of x to the 9th is 1 over x to the 9/2 power. I'm going to rewrite this as x to the negative 9/2. In part 7, we're going exactly the opposite direction. We have a rational exponent and we want to rewrite it as a radical. So we're going to use x to the m over n is equal to the nth root of x to the m power. Well, 1 is the power, 6 is the root. So this is the 6th root of x to the first power, or just simply the 6th root of x. B, 10 is the root, 1 is the power. This would be the 10th root of x to the first power, or simply the 10th root of x. This needs to be rewritten as 1 over x to the positive 1/3 power, but this is the root, this is the power, and this is 1 over the cube root of x to the first power, or 1 over the cube root of x. D, x to the negative 1/5 power will be rewritten as x to the positive 1/5 power. 5 is the root, 1 is the power. This is 1 over the fifth root of x to the first power, or 1 over the fifth root of x. E, 5 is the root, 3 is the power. This is the same thing as the fifth root of x to the third power. X to the 7 halves gets rewritten as 1 over x to the positive 7 halves, where 2 is the root, 7 is the power. This is 1 over the square root of x to the 7th power. X to the 9/4, 4 is the root, 9 is the power. This is the fourth root of x to the 9th power. And letter H, we have x to the negative 2/11. We'll start off by making that positive 1 over x to the positive 2/11. 11 is the root, 2 is the power, and it's 1 over the 11th root of x squared. In part 8, we're going to simplify each of the following square roots that contains variables in the radicand. Well, to do that, it'd be helpful to have your list of perfect squares. So, what are they? 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Well, the largest perfect square that goes into 8 would be 4. So I'm going to break this up into, in black on the left-hand side, what I can take the square root of, and in blue on the right-hand side, what I cannot. So 8 is going to get broken down into 4 times 2. And I'm also going to take a look at x to the 9th. I can remember a square root is a second root. And so a second root needs to be divisible into an even power. It's not divisible into 9, but it is divisible into 8 of those 9. So I will take the remaining 1 and place it over to the side. Now, let's take the square root of whatever I can. Remember, square root is a second root. So the square root of 4 would just simply be 2. The square root of x to the 8th would be x to the 4th power, because 8 divided by 2 is 4. And then times the square root of 2y. So anything you cannot take the square root of just simply remains under the radical. Part B, 75x to the 16th, y to the 11th. Remember, we're dealing with a second root. So 75 will get broken up into 25 and 3. Again, I'm color coding it. Black is what I can take the square root of. Blue is what I cannot. I can take the square root of x to the 16th power because 16 is an even root and 2 is divisible into 16. So I'm going to write all of those x to the 16th power right here. But I can only take the square root of 10 of the 11 y's. So I'm going to write y to the 10th times y to the first power. This becomes, taking the square root of 25, we get 5. Taking the square root of x to the 16th power, 16 divided by 2 would be x to the 8th power times y to the 5th power. 10 divided by 2 is 5. And then times 3 times y, the square root of 3y. Letter C, this is going to be 2x times, now 18 can be broken down into 9, the largest perfect square that goes into it, times 2. X to the 7th can be broken down into x to the 6th times x to the 1. Why am I doing that? Because a second root can go into 6 3 times. This is going to be 2x times the square root of 9 would be 3. The square root of x to the 6th power would be x cubed. 6 divided by 2 is 3. All times the square root of 2x. Now what we'll do is we'll just put things together. We know that 2 times 3 would be 6, and we know that x times x cubed would be x to the 4th power, and then just times the square root of 2x. Part D, 3x squared y, start there, times the square root of 98 x to the 5th y to the 8th. Well, the largest perfect square that goes into 98 would be 49. So let's break that up into 49 times 2. A square root is divisible into 4 of those 5 x's. So I'm going to put x to the 4th over here. And I'm going to put x to the 1 over here. X to the 4 times x to the 1 is x to the 5. And 2 is divisible into 8, so I'm going to write all 8 of those y exponents over here. Well, let's go ahead and take a look at this. This would be 3x squared y times the square root of 49 would be 7 times the square root. Remember, square root's a second root. The square root of x to the 4th would be x squared. 4 divided by 2 is 2. And the square root of y to the 8th power would be y to the 4th power. 8 divided by 2 is 4. All times the square root of 2x. So just sort of cleaning this up, 3 times 7 would be 21. X squared times x squared would be x to the 4th power. And y to the 1st power times y to the 4th power is y to the 5th power. All times the square root of 2x. Part 9. Evaluate each of the following roots in simplest radical form. Notice in part 9, all the roots are cube roots, so we need to make a list of our perfect cube roots. Well, the list of perfect cubes would be 8, 27, 64, and 125. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. We need to know our perfect cubes in order to do this exercise. Well, 16, the cube root of 16, x to the 8th is going to be broken down into 8. That's the largest perfect cube that goes into 16, times 2. Now, we're looking for what is divisible by 3, because we're talking about a cube root, a third root. Well, 8 is not divisible by 3, but 6 of those 8x's are. The remaining 2 x's will go over here. X to the 6th times x squared is x to the 8th. This is the same as if we take the cube root of 8, we get 2. The cube root of x to the 6th would be x squared, because 6 divided by 3 is 2. All times the cube root of 2x squared. Letter B, the cube root of 108 x to the 5th, y to the 10th. Well, what's the largest perfect cube that goes into 108? Well, that would be 27. And it goes into 108 4 times. I'm going to put a 27 on the left side in blue and black, 4 on the right side blue. Now, this cube root goes into 3 of those 5 x's. So x cubed goes here, and x squared goes here. So x cubed times x squared is x to the 5th. Lastly, this third root goes into 9 of those 10 y's. So I'm going to put y to the 9th power times y to the 1st power. Okay, take the cube root of what you can. This is a cube root there. Take the cube root of what you can. Leave under the radical what you can't. The cube root of 27, start there. That would be 3. The cube root of x to the 3rd would be x to the 1st power, or x to the 1. Because 3 divided by 3 is 1. The cube root of y to the 9th power would be y to the 3rd power. 9 divided by 3 is 3. All times the cube root of 4x squared times y. See? We can already take the square root of 64, so I'm going to leave that there. I can take the cube root of x to the 12th because 3 is divisible into 12. I cannot take the cube root of y to the 14th power. So I'm going to break that up into y to the 12 times y squared. Well, the cube root of 64 would be 4. Cube root of x to the 12 would be x to the 4th power. 12 divided by 3 is 4. Cube root of y to the 12th power would be y to the 4th power for the same reason. And then what's left under the radical is the cube root of y squared. We're done. The cube root of 375, x to the 7th power, y to the 11th power, can be broken down first into 125 times 3. That's the largest perfect cube that goes into 375. X to the 7th can be broken down into x to the 6th times x to the 1, because the cube root, a third root, goes into 6 of those 7 x's, 2 times. And then y to the 11th, a cube root can go into 9 of those 11 y's. The remaining 2 go over here. This becomes the cube root of 125, which is 5, times the cube root of x to the 6th, which is x squared. 6 divided by 3 is 2. Times the cube y to the 3rd power. 9 divided by 3 is 3. All times the cube root of 3x times y squared. Number 10, Michaela was trying to rewrite the expression 25x to the negative 1/2 in an equivalent form that is more easy to use. She incorrectly wrote it as 5 times the square root of x. Explain Michaela's error. Well, Michaela made an assumption that the 1/2 power applies to the 25 and the x. The 1/2 power only applies to the x. In other words, this is 25 times x to the 1/2 power, which is 25 times the square root of x. Michaela's assumption was that the 25 also was included in this 1/2 power, which is the square root of 25 times x, which is 5 times the square root of x. So her assumption was that the 1/2 power applied to the 25 as well. Without parentheses blocking that off, this really is just 25 times x to the 1/2 power, or 25 times the square root of x. Again, pause and rewind the video as necessary. I hope you were able to get something out of today, and thank you.